Hi everyone. If you don't know me, my name is Samir, and I'm one of your TAs for CS 2110. And today I'm going to be going over GDB, which is a debugging tool that we use pretty extensively for C programming. In general, it's a good way to learn how to debug your C code. It's very commonly used in future classes and in industry as well. So, without any further ado, we will go through how to make the metal rectangle full of little lights do what you want it to do. All right, so as I'm sure you guys know, we spend a lot of development time fixing code. So, sometimes you have to fix something like a segfault. GDB can help you with that, but also logical errors, runtime errors, things that are a little bit more subtle are harder to fix. And you can use printf or, the equivalent for whatever language for some basic debugging, but using a tool that's specialized for the job, like GDB, is generally a much more productive and effective way to fix bugs in complex software. Which, brings us to GDB. It's a command line tool. It's packaged within our Docker container that will let you poke around your code, print stuff out, inspect variables. It's very powerful. It can save you hours. It has saved me hours in many classes. And for this class, again, it's packaged in the Docker container, so it's easier if you run it there because our Docker container already has all the other dependencies you'll need for the autograders and such. But it can also be installed using whatever package manager you want, and you can get it on Windows too, I think. Um, so to get started with GDB, the first thing you need to do is compile your code with debug flags. And that's what this -g here does. It just inserts some extra information into that executable that GCC generates that GDB will use to help you debug. So this is basically your command. The -g is going to make GDB work, and then you have your normal -o to set the name of the output file, and then you pass in the source file. And any of the make files we give you for the intro C homework, the dynamic memory homework, these sorts of things will automatically do that for you when you run make tests. So then we can use GDB. And as I mentioned before, it's a command line tool. And to run it, you're going to do GDB and then the name of your output file. So by default, that's a.out or whatever you set in -o. And you have to make sure you pass it the output file and not a .c or a .h or a .o file. It should be that output that was generated by GCC. And then there are a bunch of commands you can run to help you debug. So the first one that you're sort of always going to start with is run. And you can pass in any arguments, and that's going to run the program you're debugging. So that's very important. So like, if I were to run my program that was called test, I could do /test normally. But if I wanted to run it in GDB, the first thing I would do is GDB test. And then when I actually wanted to run it, once I got in that GDB window, it's going to give you a little prompt like this. And you would just type run. And if you had like two arguments, like it'd say the string arg and then 3, that might be how I'd run it regularly. So I'd still just do GDB test, but then when I did run, I would do run arg 3. So that one's pretty straightforward. Next is break, and that's going to set you a new breakpoint. So this looks very similar to breakpoints in complex. What we can do is it will run the program until we hit the breakpoint, and then at that point it will be stopped, and we can run other commands that might be helpful. Where can be a function name, so that would be as soon as you enter the function at the very top. It can also be a line number or a file followed by a line number. So if you have multiple files, it might be useful to do like, homework7.c:55, and that's going to tell GDB to stop at line 55 of homework7.c. If you just have one file, I could have just done 55, and then again, I can do a function name like main, and then you would not put the. I do not think you put the parentheses there. We can also implement watchpoints, which are sort of very similar to breakpoints. But breakpoints stop when you reach a certain part of your code. So when I reach a function or I reach a line. A watchpoint is going to stop when I see a variable or an expression change. So for instance, if I have a global variable like I don't know, called global GLBL, I could watch it, and when that global variable changes, GDB is going to alert me. It's going to say this is the old value, this is the new value, this variable has changed. And so that's super helpful. The program's going to pause, and we can run our other commands. We can also set it on an expression. So if I had a global array of structs or something, let's say a global array called expressions. So I could do watch expressions 3, and then if that struct had a member called like string, I could do that. And it's just basically whenever this whole thing changes, the value of this changes, GDB will alert you and pause the program. Okay, so that brings us to like sort of the next sort of more debuggy commands. So step and next you've seen before in complex probably. So step is going to it's equivalent to the step button in complex, and it'll run the next line of code and step into any functions. So if I'm running main and I have a function call, and then I don't know, in y equals 3, and then in that function call, I have int x equals 5. I don't know. Presumably these functions do other things too, but for our example, this is good enough. So let's say I've just started running, and so I just want to step. If I type step, that's going to step into that function, meaning the next line GDB is going to show you is this one. Next is a very similar thing, but it's going to step over any functions, meaning that if I run next, we would start, and we started here, same place, it would skip over this function call and do this. So it would run that whole function, determine the return value, return it, and go to the next line. So again, step is going to step into functions, next is going to step over functions. And again, this next is going to look like that next line button that you see in complex. Cool. So next up we've got print. I can print a variable or an expression. So if I want to print foo, it would print the value of that variable foo. I could also print, some sort of long expression, pointer to bar 3.str. Like, again, any sort of expression you want to put in there, it'll tell you what it is. Display is very similar, but it's going to keep printing. So let's say I display foo. It's going to print the value of foo, and then there's going to do a step. It's going to do the step, it's going to run the next line of code, but it's also going to print foo again. And then if I step again, it's going to step again, and it's going to print foo again. So print will print once, and display will continually print the thing every command after that. And if you ever want to stop, you can just undisplay foo, and it will stop displaying it. The last thing could be backtrace. So one thing you guys might be familiar with Java is like a stack trace. So like, I don't know, it would say like java.lang.nullPointer exception at file.c55 at other file line 63 ... and it's going to show you all of those function calls leading back to your main function. And so that's really helpful for debugging. But in C, especially when you get a segfault, it's just going to say segmentation fault, core dumped. And that's pretty much all that's printed, and that's not very helpful. So we can use this backtrace command to print this call stack, which will be really helpful for debugging those segfaults. So without any further ado, let's go through some debugging examples here. Okay, so I've got my first example here. So this is sort of a contrived example, but it's going to work well for our purposes. And so I just sort of wanted to go through the basics of running a command and running a program in GDB, and also using breakpoints to help find bugs. So I've got all these functions here. They all just print a bunch of stuff if there's if depending on the number that's passed in. But if the number that's passed in is not one of these numbers in the list, it's going to try to dereference what's at address 0 instead of 0. And so this thing is always going to cause a segfault, because again, we're taking the thing 0, converting it to a pointer. So now we have a pointer to the address 0, which is not a valid memory address. That's usually used for the operating system and all that. And then if we try to dereference it and set it to a value, we're going to get a segfault. And this is true for all of them. So again, very contrived example, but this would be pretty impossible to debug by hand. So let's go ahead and see how we can use GDB to debug it. So the first thing I'm going to want to do is compile it. So I'm going to do GCC, and I'm in the Docker container right now, by the way, guys. So any command I'm running, you should be able to do from there as well. So GCC -o segfault. So again, I'm going to generate that output file called segfault, and my input file is called example0 segfault.c. And then the last thing that you don't want to forget is -g to generate that debug information that GDB needs. So real fast, if I forget to do that, so let's say I'm just running normally. I don't think I need to debug because I think my code works perfectly. And so I'm going to run /segfault, and I see, oh no, there is a segfault. So let's see what happens if I just try to GDB that. If you look right here, GDB is going to warn me there are no debugging symbols found in segfault. And if I try to do pretty much anything except like run it, so I ran it and that worked. But if I try to do like anything else, continue, or like print the values of some function output, this is not a good example to show this, but it would not really work. And it's not really giving me line numbers. It's not super helpful. So again, we're gonna wanna compile with that debug information so that GDB can help us out a bit. So now that I compile it there, I'm going to go ahead and say GDB segfault, which is recompile with debug information. And you can see I no longer have that warning. It says reading symbols from segfault, which is exactly what we want. So now I'm going to go ahead and run segfault. And again, I have a segmentation fault, but this time it's showing me where it is because I have that debug information. So if I really want, I can print the backtrace. It's not super helpful in this example, but we can see, so at main, in line 32, I've called this function df27 with this parameter. Line 32, 47e1. And at line 47e1, at line 948, we're segfaulting. And so if we go back to line 32, we can see that 153885 is the parameter passed in, but that's not one of the numbers here. So I'm going to go ahead and just copy one of the numbers here and put it back into our function call. And so now that one's fixed. Again, sort of a contrived example, but we're going to do it. So I'm going to type all lowercase quit to exit GDB. You can also hit Control-D, same thing. And I'm just going to recompile. So we fixed our bug, no compile errors. Let's just run it again. So now you're noticing that was line 900 something. We still have a segfault, but it's at a different line. So we fixed that one, but we have another one. And it's the same sort of issue here. So we have all these numbers that are valid inputs, but that's not the one that we selected. So I'm going to copy one of these correct numbers, and I'm going to print the backtrace, which is again, you can type backtrace or BT to do that. And it'll show us the line number where we called it. And so that's going to be line 63. So I'm going to go over there and paste that number. And once again, I'm going to recompile this program. So, and again, no compile errors. And unfortunately, it's still not working. We've got one more segfault, this time around line 400. So again, just going to copy the info. I'll print out that backtrace, to see where the function is called, and that's going to be at line 84. And hopefully, this time it should work. So I'm going to go ahead and run it, and nice. So after all these miraculous prints, it's going to say, congratulations, you debugged this program. Checking the backtrace is vital for debugging segfaults. So that's the output of this program. That's the intended result. So again, kind of a contrived example, but it shows you how GDB can help you debug an example that is more complicated than your standard program. Okay, so I'm going to go ahead and continue on to the next example, which is perhaps a little more useful. It's very similar. So I have this this program that's supposed to print the index of a string. And so I'm gonna go ahead and quit, and I'm gonna just remove that segfault file so I don't have it lying around. And I've been compiling it, and it doesn't seem to work. I don't know what's going on. So I'm gonna compile debug information because I know I'm gonna need to debug it. But it's example 1. So I've created this index of file, and when I run it, and I've got these 3 test strings at the bottom. So I'm using 2110. I'm trying to search for the character 2, the character 1, and the character hashtag. So these 2 should succeed. They should find 0 and 1, because that's the index of 2 in 2110 is 0. The index of the first occurrence of the 1 in 2110 is 1, and this should return -1 because it's not present. So that's what we're expecting. But if I run index of, I do get the correct results for the first 2, but for some reason my code seems to be segfaulting on that last one. So let's go ahead and see what we can do to debug this. Again, segfaults can be very hard to debug with regular debugging techniques. So I'm gonna go ahead and throw this guy into GDB. So GDB, the name of my output file, which is index of, and let's just run it and see what happens. It's just warning me that the source file is more recent than the executable but that's just because I added these comments, so I'm just gonna ignore that for now. So we're seeing I'm segfaulting on this line if string equals C. So as a reminder, a segfault occurs when we're trying to read an invalid memory address. And you can even see it right here. GDB is telling me it cannot access memory at this location that's been passed in as a pointer. So that's super weird to me. I'm just passing in strings. I'm totally allowed to read those. I'm not too sure what's going on. So, by the way, one thing I should have quickly done is explain what this program does. So we're going to pass on a string. If the character at the front of that string is the character we're looking for, then we're going to return 0 because it's at the front of the string. Otherwise, we're going to add 1 to the string. So again, pointer arithmetic, it's just going to basically move. So if I have the string 2110, and then our pointer is pointing to that first character. So that's going to be right there. But if we add 1 to it, we're going to now have a pointer pointing to the second character. And so basically we're passing in the string 110. So what we'll do is we'll call index of on basically the string with that first character cut out, and then we're just going to add 1 to the result there. So the idea is that we'll recursively iterate through, and since we're always cutting out the first character, if it's in the string, then then it'll eventually return 0, and then we're just going to add 1 to it every time as we go back up the call stack. And then if it returns -1, then we know it wasn't found, so we're just going to return -1. So that's what's going on here. But again, I seem to be segfaulting, and that is sad. So let's go ahead, since the segfault, I'm going to print that backtrace. And wow, that's a lot of function calls. Like a lot. Like a lot. So yeah, well, we'll let it do its thing. I was only expecting a couple of function calls because I called it with 2110, and then it would say, okay, the first character's not a hashtag, so it's going to check 110, and it's going to check 10, and it's going to check 0, and then they're just on the empty string, so it should be okay, there's no character there. But it doesn't really seem to be stopping. I went ahead and hit C, which is going to continue and automatically go through. I'm going to go ahead and hit Control. Oh, GDB is not happy with me. Okay, there we go. Managed to get out by hitting Control D. I've also managed to exit my Docker container on accident by hitting it twice, so we're going to get back in there. But this is super weird. So, I don't know what's going on. I wanna step through this code and see what's happening. Why is it not terminating when it should? So, we're gonna go to GDB demo. Perfect. Okay, so let's take a look at this code. We're gonna go back into GDB index of. Perfect. And let's see what's going on. So I'm going to set a breakpoint on main. So main is the first thing that's actually run. So we're immediately going to break as soon as we start, but I want to be able to step through. So, and actually I'm going to recompile it real fast so I get the correct line numbers when I'm stepping through. So, because remember that I've added these comments since then. So we're going to just recompile, G for the debug information, O to set the output file is going to be index of, and then example 1. Okay, perfect. So now we're going to run GDB, and I accidentally typed index instead of index of. Okay, so we're going to set a breakpoint on main, and we're just gonna run through. So we're running. We immediately stop because the main is the first thing that's run. So I'm just gonna sort of step through. So step. Okay, so we're on this first line, which is going to be, it's going to call string index of, and it's going to pass that on to printf. So I'm going to step, and I'm not going to type next. I'm going to type step because I don't want to step over that function call. I want to step into the function call of string index of. So let's see what happens. Okay, so we've got a call to string index of. I'm passing in some string here, and you can actually, so one thing you'll notice with GDB is the instant you step into a function, a lot of times these parameters that are on the stack that it's telling you don't make sense because it hasn't set up the stack yet. So usually if you do one more step and then you try to print out their values, so I print out string, it'll show you the actual values. So that's just a little tip there. That's weird. Oh, sorry, I meant to say print C, not strc. So, okay, so we can see that our string is 2110, and C is the ASCII character 50, which corresponds to the number 2. So this is really what we expect. The first time we expected 2110, 110, 10, 0, empty string. And then we always really expect the character to be C and not change. 2 and not change. And actually, what I'm going to do is, I just realized, I already know that these first 2 function calls are working. So I don't actually really need to step through this. So what I'm going to do is I'm going to type finish, and that's going to finish our current function call. It's going to return, and we're just going to go next. We're going to skip over these 2 lines that we know are working. And this is really the one we want to step into, where our character is that hashtag. So we go here, we're going to print the string, we're going to print C. So this is what we expect for our current iteration, but again, at some point we're not working. So the first thing is this first character a hashtag? It is not, so don't expect to go into this if statement. And as we expect, when I step, instead of going to return 0, it skips over and goes here. Okay, so now we have another function call, and we expect it to be 110 and 1, or in hashtag, which is, let's see if that's what we get. So again, we should do an extra print step before we print everything. And yeah, indeed, our string is 110 and hashtag. So I'm going to keep stepping, and so this time we expected the string to be 10 and hashtag. And again, we don't expect to go into the if statement because there is no hashtag in the string. So 10 is in fact our string, and hashtag is our character. So that's all fine and dandy. We're just going to keep stepping, and I'm going to keep going until I notice something wrong. And what I'm noticing right now is I'm typing print string and print C a lot. So I'm actually going to add those as displays because that's just going to save me some time. So again, every time when I do a display, every time I run a command, it's going to print the output of string and C now, which is a little easier. Okay, so again, our string is 0 and our C is hashtag. So we're correct. We expected to skip the if statement, and so now we have the empty string and a hashtag, which is also what we expected. So now our first character is going to be that null terminator, and our character is still that hashtag. But now I see the problem here is that we don't really have any base case. It's just going to keep trying to add one to that string. And now we're reading some sort of like random invalid string from memory. Like this is actually that format string from printf because it's reading off another part of the stack. And I just realized it's never actually going to stop. So again, stepping through GDB, printing out values that are helpful to you is a good way to help debug problems like this. So I'm going to go ahead and add that base case. If we've reached the end of the string, so if we've reached that null terminator, let's just return -1 because we know that we haven't found it. And then when our previous function calls c that we return -1, they're also going to return -1 because of this ternary statement here. Which, by the way, for those of you who aren't really familiar with it, it's like if previous is -1, we're going to return -1, else return a 1 plus previous. That's what's going on with this whole question mark colon dealio. But anyway, now that I've added that base case, I'm hoping I've fixed my infinite recursion. Let's see what happens. So we're gonna run GCC again. We got to recompile our code, and yeah, let's see how that goes. So I'm just gonna run it normally from my command line, and which is 0, 1, and -1. So perfect. All right, so that's it for that example. The next one's going to be a little different. So it's not segfaulting, but it's not doing what I expect. So this code does two things. It's going to do some math, and then it's going to print out the first few characters of a string. But for some reason, I'm just not getting the right result from my math expression, and I don't like that. So I have these numbers A, B, C. I have this string, and I have this struct where I'm going to hold the results. So we're going to multiply together these three numbers, and then we want to try to get the first half of the string. And so let's just go ahead and see what's happening right now. So I'm gonna remove index of just to not have that extra file lying around. But let's go ahead and run our compiler. No compile errors, but let's see what happens when we run it. So I'm going to tell you right now, 211 times 2 times 5 is not it's not that number. It's actually 2110. And how long's our string? It's actually going to be so we do seem to get this is the first half of the string, which is what we expect. But something's going on with our math. So what I'm going to go ahead and do is figure out, try to find the exact moment where a variable changes to an incorrect value. Again, the one that's wrong is this result from the math. So I'm gonna do this. I'm gonna go ahead and take a look at this results.math. So there are two ways to do this. What the comments suggest from this example is that you set a breakpoint and sort of step through and use continue and print and display to figure out where things went wrong. I'm actually not going to do that because, first of all, it's what I did in the last example, so you guys already know how to do that. But also, I want to show you guys watch points, which again, we can watch the value of a variable and can see when it changes. So let's go ahead and do that. So I'm going to go into str math, and I'm going to watch this result that's incorrect, which is results.mathResult. So again, whenever this expression changes, GDB is going to warn me. And actually, it's telling me I can't watch that because I don't know what results is. So we're going to have to wait until results is defined to set that watch point because it doesn't know what I'm talking about. So I'm going to set a breakpoint on line 25. So before line 25 is run, and again, you can either just type the line numbers in as one file, or you can just, if you have multiple files, you do that. So we're setting our breakpoint there, and so we're going to go ahead and run, and it's going to stop right here, which is again right before this results thing is declared. So that's exactly what we want. So now I'm going to set that watch point I tried to set. Okay, so I've got this hardware watch point, and it's going to tell me whenever results.mathResult updates. So let's see where it goes wrong. Let's continue. Okay, so we can see we had some old garbage value here, because again, we're initializing in the stack, so there was some garbage data in here before. So that was the old value, and our new value is 2110, which is what we expect. So honestly, what gives? Like, I set it to the correct value here. I don't seem to be changing it later. What could be happening? So I'm going to continue. I'm going to continue, and let's see what happens. By the way, I typed C before. That's a shortcut for the continue command. I've gotten very used to these shortcuts, so you might see me use them occasionally. But again, that continue command is just going to keep executing once you've been stopped from a breakpoint or a watch point. So let's go ahead and continue now. And actually, something weird is going on. It's changed again. It's changed from 2110 to this garbage value inside strn copy, which is like a... we're not even touching that string result, that math result. So what could be happening? So let's think about this strn copy. So our string is how long? It's 1, 2, 3. Actually, I'm not even gonna count it. I'm gonna make GDB tell me. So I'm gonna print strlen of results dot string result. Oh. It's telling me there's no symbol results in the current context. And the reason for that is, if we look at our backtrace, the current context is always going to be this number 0 unless you set it to be. And so that's going to, like, we're somewhere deep inside the C library right now. Like, it's taking us to code in here that, like, is not stuff I've written. So if you wanna change that context to be able to print values variables elsewhere, we can use a frame command. And so I want to be in this frame right here in my backtrace, which is in main. So I'm going to say frame 1, and that's just based on this number right here. So that's going to say, okay, this is actually the part of that stack frame where I want you to print from. And then when I print the strlen, we can see that the string is 38 long. So okay, let's see what's going on basically. So we're going to copy. Oh, sorry, I actually meant to print out the length of my original string. So I'll print this string right here is 76 long. So what does this become? We're going to copy into results.string result. We're going to copy out 76 divided by 2 is 38 characters from string. And so let's think about this. What's happening? So I have my buffer somewhere in memory, which is going to be a in a struct, I have this buffer that's like 32 long. 1, 2. I'm not going to draw out 32, but it's some amount long. And then I have this string I'm trying to copy in, and so it's going to copy in characters. THIS space IS TH, and that wasn't quite 32, but it's going to copy over 32 characters, and then at some point it's going to reach the end of that buffer because the buffer only has space for 32 characters. And then it's going to start writing elsewhere in memory. And we don't really want that. And it's going to write that null terminator. And so what's happening is that we have our struct here that has the string result, and we're overflowing the size of this array, and then it's writing into what's next in memory, which happens to be this math result here. So this is bad. This is not what we want. And so what I'm going to go ahead and do is just make that buffer a bit bigger to make sure that it has space to hold my results. So I'm just going to double it. That's more than enough space because we only need to copy 38 characters. And so that's why our math result value was changing when we were only modifying the string result, string copy, because we were overflowing that buffer. So let's go ahead and see what happens now. So I'm going to recompile, and then I'm going to run it. And so the result was 2110, and the first half of the string this is the first half of the string. So that's perfect. This is exactly what we want. We got that extra space because the word second is a little longer than the word first. So, perfect. This one is deep. Okay, so I just have a couple of more examples now. So here's one more where I'm not quite getting the correct value. So in this example, I'm trying to convert a string to its LeetSpeak version. So this is sort of a simplified LeetSpeak where I'm going to replace all the lowercase o's with zeros, all the lowercase l's with ones, all the lowercase e's with threes, all the lowercase s's with fives, and all the lowercase t's with sevens. So like the string LeetSpeak is going to look like this. And then they'll return a pointer back to that original string. So I've got these strings that I've allocated on the stack, because as a reminder, if I pass in a string literal, that's read-only memory. That's no good. So I make space for them on the stack by making them arrays, and then I pass them in, and I'm going to print out their LeetSpeak versions. And it sort of works, but like, well, let's see what's happening. So I'm going to compile that LeetSpeak file. So, example3 LeetSpeak.c. It compiles normally, but when I run it, I'm not getting the expected result. So all caps should not change because it's all caps, and that's actually what we get. But for access denied, instead of getting these numbers, I just get, there doesn't really seem to be anything there. And then even weirder, for mainframe online, it's not that I lose this 3 and then also everything after it. And so I'm just like incredibly confused about what's going on. I don't know why I'm losing characters. I don't know why I'm only losing like these characters in the second one, but then I'm losing like this N and this I here as well that aren't supposed to be replaced. So like, frankly, I have no idea what's going on. So I'm going to debug this in a very similar way to my string index of. I'm going to skip over the parts that are working and step in and see what's happening for the parts that aren't. So, yeah, without any further ado. So I already know that this one's working. So I'm going to set my breakpoint right here on line 29. So we're going to break on line 29. And again, so there's only one file. It knows where to look. And we're just going to run. Okay, so it does the all caps. It prints that one out correctly. And so now let's go ahead and step into this function. We're going to do that extra step to get the proper parameter. So I print the parameter, this is access denied, which is the string I was looking at. And the first line I have here is this int I equals 0 for loop. And I'm actually not going to step, because if I step, it's going to step into the strlen function, and that's not going to be a good time. I know strlen works. It's a C library function. Like, let's just skip over that. So I'm going to type next to go to the next line. Okay, so I is 0 because we've just started this for loop. So the first character of the string is A. So we don't really expect this one to be replaced. So let's go ahead and skip past all of these lines. Okay, so we've skipped out this, and if we print out the string, we should expect that that character was not replaced. So let's see what happens. Not replaced. So far, so good. And then, so I'm basically going to do the same thing with these C's, because I also... Oh, I think I messed things up by accidentally stepping into strlen. So I'm going to run it again and sort of continue where I left off. So I'm just going to use next, because I actually don't really need to be using step for this function at all. Also, as a little hint for GDB, if I just don't type anything in, and I hit, and it's just going to run whatever you previously ran. So I'm just going to keep hitting enter to do a next without having to type next every time. Okay, so we're going through. Again, we didn't expect that A to be replaced, so let's see what happened. A was not replaced. And I'm just going to display the string so that I don't have to keep looking at that either. So we're going to keep stepping through. C is not an O, so it shouldn't be replaced. C is not an L, so it shouldn't be replaced. E is not an L, so it shouldn't be replaced, etc. Or it's not a C. So again, C is not replaced, it looks good. We have another C, and we pretty much can serve the same thing. So everything looks fine. Now here's where it first gets interesting. So again, I expect this E to be replaced with a 3, but I did not observe that when I was, it just sort of disappeared. So let's see what's going to happen. It's not an O, it's not an L, it is an E. So I'm going to pay a lot of attention to what happens after I run this next line. So first of all, let's just even like make sure that everything's written properly. So does string I equal E? We expect that to be true. And it returns 1. As a reminder, in C, any non-zero value is true and any 0 value is false. So that seems to work. So let's step over. And, oh, I see what's happening. So my string was E, and so it started a 3 there. And if you're looking here in GDB, it says \003 SS9 instead of a 3. I'm realizing this is GDB's way of printing out a an ASCII character for 3. Like that literally the ASCII character 3, I can go ahead and consult my ASCII table. That's the end of text character. That's not the number 3. That's not what I wanted. So I'm realizing what's wrong here. I need to be putting my characters inside quotes so that I get the correct values. So hopefully now that I've stepped through, and then the reason why it wasn't showing up in here is because my terminal has no idea how to print that character, so it was just sort of like skipping it. So hopefully now that I've changed all those, my program will work. And so let's go ahead and compile it one more time and see what happens. Perfect. So I get all caps, which doesn't change, but then access denied and mainframe online do what they want. And the reason I was losing these N and I characters, because this is a null terminator, because I was inserting a 0 character there, and that was ending the string. So I've solved my bug by stepping through. Okay, so that's it for sort of my introductory examples. I have one more example. It's a little bit more practical than the other ones, and I'm actually going to be showing you guys my homework 7 file from when I took the class, and this is the intro to C homework. But I've introduced a few bugs into it, and so hopefully we can figure out how to solve it. So I'm going to walk you guys through the problem. The homework here was to, and I'm also going to show you guys how to run GDB with our make files and with our autograders. That's sort of the main purpose of this. So this is a really helpful one for you guys. I would stick around and figure out, try to see what it does. So first of all, we have these myString functions that we have to implement. I'm not going to be showing you guys that, but we're going to assume it works. I'm already passing all the autograder tests for those, so I feel pretty good about those. I've gone to office hours. I see that those are working. So there are a couple parts of this homework. Basically, the first thing I want to do is I have 2 functions where I need to be able to do type conversions. So I need to convert from a string that contains a decimal number to an int, and I also need to be able to convert from a string that contains a hex string to an integer. So this looks very similar to the problems we saw in homework 1, but I don't know. Things don't seem to be working. And then I'm going to use that to make a parser. So I should be able to take in strings like, there's an example here somewhere. Like 3 plus 0x40 minus 7 plus 5. So I need to be able to take a string like that has plus and minuses, and it can add and subtract decimal and hex strings. And I should be able to calculate the result and put it into a struct. So that's and then there's also this main function, but I've also gone to office hours and figured out that works, so we're going to ignore it for this example. So the structure we need to put it into is here. It's called struct expression, and basically we have this buffer. In that buffer, we're going to put in the string that we parsed. And we're also going to calculate the result and put it in our... And then we also have these error codes we need to set. So if our... I don't remember where the error codes are defined off the top of my head. Let's find out. Error codes.h, got it. Okay. So if there's no error, we're going to set the error code to 2110. But the expression is too small, we're going to set it to this. If it's too long, we'll set it to this. And if the expression is invalid, we're going to set it to this. So that's what the assignment is. But so to compile it, I'm going to run make tests, which is going to run the autograder. Okay, I'm going to run... There's some sort of bug going on with this make file that's telling me it's always up to date even when I change the file. So I'm just going to run make clean and make tests. I can't type. Oh dear. Okay. To recompile that autograder. And when I run it, I seem to have some sort of infinite loop. It's just not stopping. And then it does something, but then it just still doesn't stop. I don't reach the end. I don't know what's happening. So I'm going to kill it, hit Control-C. And we can also use GDB to debug infinite loops. So let's go ahead and see what's happening. So to run GDB on your autograders, there are 2 ways to do it. If you make tests, you can just do GDB tests, and that'll work normally. An equivalent way to do that is to also do make run GDB, and we just sort of define that for you, and it's gonna run it for you. So that's another way to do it if you want. Either way, so that's how we can open up the autograder with GDB in our using our 2110 make files. And so I'm gonna run this and see what's happening. Actually, before that, why don't I walk you guys through my code? I just realized that I haven't really explained how it works, and you guys might appreciate that. So, let's go ahead and take a look. So, I have this decimal string to int function, and I should say 1. That's a typo. So the way this works is that I go right to left through the string, or sorry, left to right through the string. So, sorry, I'm gonna figure out my workspace here. Okay, so if I have the string like, why can't I draw? There we go. So if I have the string 2110 as a decimal number, I'm gonna start at the left side of the string, and I'm gonna have this int, which is int val, that starts at 0. And then the first time I iterate through the string, I'm going to read that first character of the string. It's not 0, which is a null terminator. So what I'm going to do is I'm going to shift val over to the left, which does nothing. And then I'm gonna convert from ASCII to hex digits by subtracting that ASCII value for 0. And I'm gonna add it to my value. So I'm gonna make value set to 2. And then I'm gonna look at the next thing in the string. I'm gonna do string plus plus, and it's gonna look at the next character. And what's gonna happen then is I'm gonna shift it over to the left. So I've shifted the character over to the left by 1, and since it's decimal, it's gonna become 20. And so then I'm gonna add that 1, and then I'm gonna shift it over to the left by 1 again. That goes to 10, and I add another 1. I'm gonna shift it over to the left by 1 more time. It goes 2110, and that becomes 0. And again, so then I'm gonna return it, and we'll be done. String to int is pretty much gonna work the exact same way. So if I have my another hex string, so let's I don't know, B33F 0x. So we're gonna sort of assume that the 0x is not passed in. So we're gonna start at that B, and so we're gonna have int val equals 0, and then we're sort of gonna shift it over. So we start with 0, and then if it's a decimal digit, we're going to do the same thing. If it's a hex string, we're going to subtract, and by the way, we're assuming, this is a safe assumption for this homework, that all our hex characters are capital. So if it's a hex digit, then we're going to subtract that value for A. So the character A, for example, then we subtract A, so that gets 0, and then we're going to add 10, because A corresponds to 10, B adds to 11. So like if it's A, this is going to become 0 plus 10, which is correct. If it's B, so it becomes B minus A is 1, plus 10 is 11, so that's also correct, etc. And then we add it to our val, and then we just keep iterating through. So it's pretty much the same. We're just sort of going to keep going left to right and shifting over and drawing. So that's how those two work. We also have this parse expression function that is going to go through and try to create our expressions. So the way this one's going to work is that we have our expression, so like, I don't know, 3 plus 0x AB minus 74. And so the way this sort of works is by going on through the different characters, and so okay, again, we're gonna iterate left to right through the string. So first we're gonna check if it's too long or too short. We'll set the appropriate error codes, but then we're gonna go left to right through the string, and we're gonna have this value variable that's gonna keep track of something. The current term, we're gonna have a sum which keeps track of the sum total of our expression. We're gonna keep track of the current base and the current operation. So I'll explain what all those do in a second. So we go left to right, and we sort of parse the current term using the functions we have. So I'm going to start with this term here. And so our current value is going to be 3. Just going to parse that first term. And by default, our operation is going to be 1, which is addition, and our base is going to be 10. And so we're going to add, so since we see that the operation is 1 and the base is 10, we're going to add 3 to the sum. And then again, we're going to go here, we're going to see 0x, so we're going to say, okay, we're in base 16. And that's going to tell us to parse these next few characters as a hex. And actually before that, we even see this plus, which says that our operation continues to be addition, so we're going to keep operation as 1. So when we parse this, the string AB is equal to 171, I think. And then, since we see that once we reach the end of the string, we're going to see that our operation is 1, and so we're going to add this, and we're going to get 174. And then we're going to get to the minus sign, and we're going to see that we have a subtraction. And so we're going to set the operation to -1, which is for subtraction. And then since we see that there's no 0x here, we're going to set the base back to 10. So since the base is 10, we're going to parse using decimal. And so we're going to set the value to 74. And then, so that's going to get us 100 as our total sum. So this is the way this sort of works. So to walk you through how the code actually looks, we set our error codes. We have all these variables here. If we see that our current string is 0x, then we are going to set the base to 16 and add 2 to the string to skip over that 0x. Because again, our parsing function sort of ignored the 0x. We didn't want to pass that into the parsing function, so we're just going to skip over it. And then, so whenever we see a plus or a minus, we are going to add in that term that we just had. So the way this works is that we'll read the value that corresponds to that term, and we are going to multiply it by the operation. So if the operation is 1, it's addition, and if the operation is -1, it's subtraction. So this basically negates the term if it's subtraction. And then we'll add it to the sum. So this basically subtracts the value if it subtracts value if it's subtraction, or adds value if it's addition. So that's how that works. It's pretty straightforward. And then, since we saw a plus sign, we're going to set our operation to be addition. And we're going to reset the value. And again, if we see that 0x, we'll set the base to 16 and skip over it. Otherwise, we're going to assume that it's decimal. Subtraction works basically the same way. We're going to add in that current term, multiply by the operation so that it subtracts if it's a subtraction. And then we're going to set the operation to -1, so the next term knows to be subtracted. And then last but not least, if we see a hex character, a decimal digit or a hex character, we're going to multiply by the base to shift over 1, and then we're going to add in that current character, basically the same way we did above. So that's the way this works. And then when we're finally done, not when we're finally done. If we hit any other character, we know that we have found an invalid character. So we're going to set that malformed hex error code. And then when we're finally done, we'll add that last term, copy in the value into our struct, set the result, and say that there's no error. So that's the way this works. That's sort of the overview. You don't even know too well how this works. I spent hours on this, of course, but that's the overview, and that's what it's going to look like when we're debugging. But again, the problem is that we have this infinite loop issue here. Let me quickly go ahead and delete those annotations so that we just don't have them sitting there while we're debugging. Okay. So again, if I run it, infinite loop, no good. So we're gonna hit Control-C to cancel, and we can see where we're pausing is val times equals base. So where is that? So that's gonna be. Is that not in my? Interesting. I don't know why to find him. Oh, you know what? I had regex find on. Okay. So so we're somewhere in this while loop. This while loop, we are stopping. So that suggests to me that this while loop is the one that's going infinitely. So I don't know why that is. When we reach the end of the string, we should be done. So why don't we go ahead and step through and see what's happening. So I'm just gonna add a breakpoint on this while loop. So on line 94 of homework 7.c, we're gonna pause and we're gonna run and see what's happening. So I'm just gonna go ahead and step through. And I don't think there are any function calls, so it doesn't, or there's, I don't really want to deal with these string copy ones, so I'm going to do the next as I'm running. Okay, so first of all, let's see what our string looks like. That's weird. Okay, so this is probably one where we're looking at that malformed hex, because our string is going to be 0x377, these like weird invalid hex characters. So this is probably testing that malformed hex edge case. That's what I'm guessing. So we're just going to go ahead and step through. So the first character is not a plus. That's a random hex. It's not a minus. It's not that. It's not that. Okay. Oh, this is. Or okay, so like something has gone wrong here. Oh, sorry, this is correct. Okay, I thought I had introduced a bug that I didn't mean to introduce to this one. Okay, so what happens is this is an invalid hex character, and so we don't. It's not a plus. It's not a minus. It's not a decimal digit. It's not a hex letter. So something's gone weird. So we're gonna set that malformed hex edge case. We're just gonna step through and return. So this one seems to work actually. So I'm gonna go ahead and continue and see what happens the next time we run this. So this is gonna be another test case, and this time the string is 0x2. So we don't expect this one to be a malformed hex. Let's see what's happening. So we're just gonna sort of step through. So again, since our let's see what our string is. So we skipped over that 0x because we started with it. So our string right now is 2. And so when we step over, we should expect it to trigger this third else if here. And so we do see that that everything's working. So we're going to multiply our value by our base and add it in. So let's see what the value we got was. Oh, sorry, val. We got 2, so that's good. That's exactly what we expected. And then now it's going to keep going. And so let's see what the next character is. And so, oh, this is strange. Because before, when I printed string, it was 2. And now it's still 2. And so now I think I'm starting to see why I'm infinitely looping. I am not explicitly going to the next character. So I'm going to add this string plus plus at the end of my loop so that we know to look at the next character when we're done. So again, using breakpoints and stepping through is a good way to debug infinite loops. So now that we've added that fix, hopefully my code works. Let's see what happens. Okay, so I'm gonna run the autograder again. And I have a segmentation fault. What is happening? So it seems to be on this line, line 89. Or yeah. So if string is 0 and string plus 1 is x, so what is happening? Well, let's see. What is string? String is just our valid hex character. So why can't I read it? Why am I segfaulting when I'm trying to read it? So this is a little more of a subtle bug. Is this one that you sort of have to look at now that you know what the line you're segfaulting on is? But the problem here is that I have accidentally put equals instead of double equals. So it's trying to assign to this place instead of reading it. And you can't assign to a literal string because that's read-only memory. So, and I'm noticing that I've actually made this mistake a few other places. So I'm going to go ahead and fix that. So a good thing to do whenever you do find a bug is to check through your code and see if you made that mistake anywhere else. Doesn't look like I did that up here, so Okay, so now that I found that one, let's go ahead and keep debugging. So make clean, make tests. Okay, compiled fine, so keep running. Okay, so I've run the auto grader, but I'm only getting 70%. Some of my things are failing. And so I'm first going to debug the decimal string to int functions because they're up first, and I don't know. I'm just going to go top to bottom. So one thing you can do with our auto graders that's really, really helpful is that if there's a specific test you're failing, you can debug that test specifically. So what I'm going to do is I'm going to copy the name of this test, and I'm going to do make run GDB test equals, and then paste that. So it's going to run GDB on that specific test case and figure out what's wrong, or help me figure out what's wrong. So again, I'm just going to add a breakpoint, a decimal string to int, and let's see what's going on when the autograder runs our function. So the string is 2110, and so again, in my first loop, this is actually the example I gave. So how convenient. But our string is 2110. So let's see what I expect. So initially, val is 0. Then we're going to shift it over and add the first character to it. So first it's going to be 0, then it's going to be 2. Then we're going to shift it over and add the second character. So then I expect it to be 21, and 21.1, and then 21.10. So this is sort of what I expect to see throughout the progression of my program. So let's see what's happening. So I'm going to display val because obviously we're not returning the correct value. So by default, it's a garbage value, of course. It's going to set it to 0. Okay, so now let's step through. So our string is not 0. Okay, if we shift val over, it's still 0 because shifting a 0 number does nothing. So now we're going to add in string minus 0, and our first character is a 2. We subtract that, asking 0 to convert it. So we did get that first 2 that I was expecting. So that's pretty good. So now we're going to go again, and I try to shift it over and make space for it to be 21. So I expect it to be 20 and 21. It does not become 20, it becomes 4. So that's really weird. Why is it not shifting correctly? So this is a little misunderstanding with how shifting works. As a reminder, our number 2 is going to be represented internally as a binary number. And since it's a 64-bit machine, it's going to be a bunch of zeros and then a 1, 0. Because that's a 2 to the 1, which is 2. So when I shift it over, it shifts over to binary representation. It doesn't know what base you're working in. It doesn't know what you mean that to be. And so what happens when I shift it over is that I get this, which is equal to the number 4. So I shouldn't be using shift for this, really. That's the wrong approach. I should be multiplying by 10, really, because that's what I want. I want to shift over by 1 the decimal representation, so I can do it multiplying by 10. And so again, I'm going to check other places in the code where I might have made this mistake. And so here, I animated it again. And then I know earlier down here I was also multiplying by the base to make space. But it looks like here I actually did it correctly. I remember I figured out I did not make that mistake there. So I'm going to run that specific autograder test again and see what happens. Oh, after recompiling. Always remember that one too. It's a easy one to forget. So let's see what happens when I run. And we get 100%. Again, I only ran that specific test case, so that doesn't mean I'm passing everything, but we seem to have fixed that bug. And actually, I'm just going to run it again without running that specific test. I'm just going to run the tests and see what happens. And so actually, I'm getting 100%. It looks like my 3 bugs were this string plus, this accidentally assigning the value here instead of checking equality, and doing the shifts. So this is just sort of one way you can use GDB to debug your programs. Again, one thing to really keep in mind when you're debugging for 2110 is this make run GDB test equals, because that'll help you run specific test cases that you're failing with the autograder. So that's really all I've got for you guys today. As always, if you have any questions, please feel free to reach out to your lab TA or email me, samirsiri@gotech.edu, assuming I'm still teaching the class whenever you're watching this. And then otherwise, yeah, reach out to your TA if you have any questions. We're Post on Piazza. Have a good day, everyone.